Alright, so looking at our do now, we are given some information about some of the scale drawings here, and then we're being asked to find what the scale factor would be for some of the other combinations here. So from drawing 1 to drawing 3, we see that it is a 30%, and from drawing 1 to drawing, from drawing 1 to drawing 2, it's 30%. And from drawing 1 to drawing 3, it's 175%. So what are the scales given for each relationship? So we're going from drawing 2 to drawing 3, so that means we need to find values for that. So remember, when we do this, we're just going to make up that this is 100. So Q is equal to percent times whole. Our whole is 100, our percent is 0.3, so that would make this 30. And same thing over here, Q is equal to percent times whole. That would make this 100. Let's make this, that would make that 1.75, and times 100 would be 175. So this value would be 175. So now looking for this one, we're looking for drawing 2 to drawing 3, new over old. We're going from 30 to 175, so the old is 30 over 175. Gives us 5.833 repeating, which 2 times gives us 583.3 repeating percent. Drawing 3 to drawing 1, so we're going now backwards here. So new to old. So our old in this case is 175 over 100. Doing that calculation, we get approximately 0.571. It's rounded. So that's approximately 57.1%. And from drawing 2 to drawing 3, from drawing 3 to drawing 2, so now we're going this direction. Our new over our old. Our old is the 175. And our new is the 30. When we calculate that, we get approximately 0.171, which is approximately 17.1%. Alright, let's flip on over and look at our aim for today. Alright, today's aim, Kipsters will be able to find and use scale factor as percent. So today we're just going to be taking things one step further. We're going to find the scale factor between two particular things, and then we're going to use that scale factor to determine some value. Alright, so it tells us the distance around an entire sailboat is 28.4 units. The larger figure is a scale of the smaller drawing. State the scale factor as a percent, and then use the scale factor to find the distance around the scale drawing. Alright, so we're trying to move from our value that we have here, which is 28.4, to whatever the value would be for the larger boat. So that means in order to do that, we need to know the scale factor from the small boat to the larger boat. So in order to do that, we have to find two values that we can compare. So I'm looking for any two values where I can actually count it out, and I'm looking here right across the top. I'm going to be able to count out that value, and I'm going to be able to count out this value across the top. So I'm going to go ahead and do that, and then hopefully we can use those values to find our scale factor. So as I count, it looks like our distance across the top here is 10, And our distance across the top here is going 5, 10, 15, 20, 22. So our scale factor, we're going to use our same calculation, new over old. And notice that the scale factor has to be going in the same direction. So our old was 10 and our new is 22. So our scale factor is 2.2 or 220%. And so now if I want to use that, I know my scale factor is 220%. I can use my equation. Q is equal to percent times whole. So we're trying to find out what this 28.4 would be scaled. And so we can scale any linear distance. So using this same scale. So this is going to be 2.2 times our original, which is 28.4. Tells us our new distance for this would be 62.48 units. Alright, so we have the same thing here. Go ahead and look on your own. It says the shorter path is a scale drawing of the longer path. We know the longer path is 32.4, so this one is 32.4. And we're trying to figure out what it would be on the shorter path. So we need to find the length that would be on the shorter path. So go ahead and identify, stop and identify, and go ahead and find the scale from the larger path to the smaller path. Go ahead and pause the video and do that now. So in order to do this, we need to find two values. So I'm going to look here. I can count this one out as 6. This one here is 2. So my scale is new over old is going to be, the new is 2 over 6, which is 1/3 or 0.333 repeating. So in order to use that now, go ahead and, now that you've double checked that your scale is 33.3%, please go ahead and use that value to find the new value of the length of the path. Pause the video now to make sure that you get that done. So in order to do that, Q is equal to percent times whole. Our percent is 33.3 repeating percent, or 0.333 repeating, times our whole, which is 32.4. And when we calculate that, we should get approximately 10.8. Coming over here, we've got something that's theoretically a little bit more complicated, but not really. It says the distance between any two consecutive vertical grid lines is 1 foot, and the distance between any two consecutive horizontal grid lines is also 1 foot. I.e., it's telling us that each of these particular items would be 1 foot. No big deal. Sherry decides to actually build the garden, 75% of the size represented on the diagram. It says, what are the outside dimensions shown in the blueprint? So this is really just asking us to count what the outside dimensions are. So let's go ahead and count it, and we'll just label it up here. So it wants to know our outside dimensions. And if we count that off, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is 12 by 5, 10, 15, 20, 25, 26. 12 by 26. All right, check what are the outside dimensions. 12 by 26. What will the overall dimensions be in the actual garden? So that means we need to use our scale factor to go ahead and determine what those new dimensions would be. So I'm going to do one for the 12 and one for the 26. So go ahead and pause the video. Find the new quantities for 12 and 26 after a 75% scale. Should be Q is equal to percent times whole, which is going to give me 0.75 times 12, which is equal to 9. For the 26, Q is equal to percent times whole. Again, 0.75 times 26. And that's going to give me 19.5. Sherry plans to use wire fence to divide each section of the garden. How much fence does she need? So in order to find this, she's going to section everything off. So I actually need to find every dimension here within this entire grid, and I need to add it all together. So looking out here, we know these are 12 and 12. Or this one up here is going to be 26 because it's same length as the bottom. This line here is also going to be 26. This line here is also going to be 26 if we count it off. And then looks like the lines that we need left are kind of these ones on the inside here. So I count this one on a half. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 1/2 on each side is 10, which means this one over here is also 10. And here in the middle, 4, 12, and 14. So we could go through and we could find the dimensions of each of these individuals and then multiply each of them by 0.75 for our 75% scale. Or we could probably do this a little bit more quickly if we added it all together and just did it as one linear dimension, just like we did over here if we knew the whole thing. So go ahead and calculate how much total fencing would she need according to the diagram, and then we can use the scale to scale it down. So when I added this all together, I got that originally there was 110. So if I want to find what my scaled value is, Q is equal to percent times whole, 0.75 times 110. Tells me that they're going to need 82.5 feet of fence. Now it's $3.25 per square foot, so that's going to be $3.25 times 82.5. Find my total cost, and that's approximately $268.13.
All right, so looking at this next problem, you should be able to complete this problem on your own. So first find the scale factor and then use the scale factor to find the unknown height of the car. So go ahead and do that on your own and then come back in to check your solution. All right, so looking at this, we need to go from 4 feet to question mark. So that means we need to find the scale factor from here to there, and we can use these corresponding sides. New divided by old. And so that's going to be our new is 39 divided by 12, which should have given you 3.25. So this is our scale factor, 325%. Now we can use that to find out what our new value is. Q is equal to percent times whole, which is going to be 3.25 times our whole is 4. And when we calculate that out, we should get 13. So that would mean the height of our car is 13. Explain what each part of the equation represents in the situation. So thinking that through with your partner, we have this is our scale factor. This is your whole or your original height of your first drawing. And this is your height of your scaled drawing. One more problem, go ahead and do, or two more problems, go ahead and do this one on your own, and then check back in as well. So again, looking at this one, we are going to determine the scale factor. We'll go ahead and go from drawing 1 to drawing 2. So that's going to help us determine our scale factor. And if we're looking at the vertical height here, we're going to come and look here. This would be our question mark of what we're trying to figure out. So finding the scale factor first, new divided by old. And our new is 3.3 divided by our old, which is 2. It's going to give me 1.65. Q is equal to percent times whole. So our percent, really 165%, 1.65 times our whole, 1.1. So this is our equation. Again, explaining to your teammate how this represents your relationship here. This is our scale factor. This is our original value, and this is our scaled value. And when we go ahead and calculate that out, we're going to get 1.815. And one last problem here. It says the length of a rectangular picture is 8 inches. So I'm going to draw a sketch here. Right, rectangular picture, 8 inches. And the picture is to be reduced by 45.5 to be 45.5% of the original picture. Write an equation that relates the lengths of each picture. Explain how this is. Okay, so it's 45.5%, so I know my picture is going to be smaller. This one's actually giving us the scale. This is nice. This is kind of a throwback question to an easier day. We're looking over here. We're trying to determine this unknown value. We know our scale is 45, and I'm going to go ahead and just make that a decimal, 45.5%. So as a decimal 1, 2, that's going to be 0.455. Q is equal to percent times whole, 0.455. That's our scale factor, times our whole is 8. And Q is equal to 0.455 times 8, which is equal to 3.64 inches. All right, go ahead and finish this up and flip on over to your alone time work.